Far beyond the warm embrace of the sun lies a moon shrouded in ice. Europa, one of Jupiter's most captivating satellites. Though small in size, Europa holds a world of mysteries beneath its frozen surface, sparking the imaginations of scientists and explorers alike. Its distance from Earth, more than 400 million miles, places it in the cold depths of space, yet beneath its icy crust, there could be warmth, motion, and perhaps even life. Europa's surface is unlike anything we've ever seen. Vast plains of ice, fractured and scarred, as if a giant hand has scratched across its face. These dark streaks, called lineae, stretch for hundreds of miles, marking places where the moon's surface has shifted and cracked. But what causes this? What forces are at work on this distant world? Europa orbits Jupiter in a delicate dance, its icy shell stretched and squeezed by the immense gravitational pull of the gas giant. This constant tug-of-war generates heat deep within Europa, creating a potential energy source far beneath the surface. And where there's heat, there may be water. Beneath this frozen surface, scientists believe there lies a vast ocean. An ocean so deep, it may contain more water than all of Earth's seas combined. This ocean, locked beneath miles of ice, is a tantalizing mystery. It could be the largest body of liquid water in the solar system, but until now, we've only been able to guess at what it might hold. Our first real glimpse of Europa came from NASA's Galileo spacecraft in the 1990s. Galileo flew by Europa multiple times, capturing images of its mysterious surface. These images revealed a world that was active, dynamic, and potentially harboring conditions suitable for life. But Galileo could only scratch the surface of what Europa has to offer. To truly understand this icy moon, we need to go deeper. Enter the Europa Clipper, NASA's bold new mission to explore Europa like never before. The Europa Clipper will launch in the mid-2020s, embarking on a journey to study this enigmatic moon in detail. Over the course of its mission, the Clipper will fly past Europa dozens of times, mapping its surface, analyzing its ice, and searching for the clues hidden beneath. This mission is no ordinary flyby. The Europa Clipper is equipped with state-of-the-art technology, designed to penetrate the ice and reveal the secrets of the ocean below. With an arsenal of powerful instruments, the Clipper will study Europa's surface, atmosphere, and magnetic field, piecing together the puzzle of what lies beneath. One of the most advanced tools on board is the ice-penetrating radar. This radar will allow scientists to peer beneath Europa's icy shell, measuring its thickness and mapping the hidden ocean beneath. By analyzing the ice, the Clipper will help us understand whether the water is near the surface or if there are pockets of liquid within the ice itself. But that's not all. In recent years, scientists have discovered something extraordinary: plumes of water vapor erupting from Europa's surface. These geysers, similar to those found on Saturn's moon Enceladus, may provide a direct window into the ocean beneath the ice. The Europa Clipper will fly through these plumes, analyzing their composition and searching for organic molecules, the building blocks of life. If these plumes contain signs of organic chemistry, it would be a tantalizing clue that Europa's ocean is not just a frozen wasteland, but a place where life could exist. Here on Earth, life has found ways to survive in the most extreme environments. In the deep oceans, far beyond the reach of sunlight, entire ecosystems thrive around hydrothermal vents, cracks in the ocean floor where heat from the planet's core escapes. These vents provide the energy needed to sustain life in the darkness, with organisms feeding on the minerals and chemicals that pour out from below. Could Europa's ocean be home to similar life forms? If Europa's ocean floor has volcanic activity, it could provide the same kind of environment that supports life here on Earth. The interaction between water and Europa's rocky core might create the conditions for simple organisms to evolve, isolated from the surface and thriving in the cold, dark waters. Cut to speculative visuals of microbial life evolving in Europa's ocean, surrounded by volcanic vents. If life exists on Europa, it may have evolved in isolation for millions, perhaps billions of years, following a path of evolution we can only begin to imagine. But until we explore further, the question remains: is Europa's ocean truly a cradle for life, or just a barren expanse of water frozen in time? The Europa Clipper is humanity's next step in answering these questions. It represents our most ambitious attempt yet to explore a moon beyond our own, and the data it collects could reshape our understanding of the solar system. As the spacecraft gathers information about Europa's ice, its ocean, and its plumes, we will inch closer to understanding whether life exists in these distant waters. Imagine the moment when the first hints of life, tiny organic molecules or the traces of microbial activity, are detected. It would be a discovery that changes everything, proving that life is not unique to Earth, and that even in the cold depths of space, life can find a way to survive. Europa's mysteries are waiting to be unlocked, and the Europa Clipper will be our key. What we discover on this frozen moon could change the way we view life, our solar system, and our place in the universe. The journey to Europa is just beginning, and the future of exploration holds endless possibilities. What makes Europa so intriguing is not just its frozen beauty, but its potential to harbor life beneath that icy shell. With a global ocean hidden beneath the surface, Europa may provide the conditions necessary for life. Conditions that, while extreme, could be surprisingly familiar. On Earth, life thrives in some of the most extreme environments imaginable. Deep beneath the ocean, where sunlight never reaches, entire ecosystems flourish around hydrothermal vents. These vents spew heat and chemicals, providing the energy needed to sustain life, without the need for sunlight. Could Europa's ocean be home to similar hydrothermal activity? If so, it might offer the same kind of environment we see here on Earth, where life could survive not by photosynthesis, but by chemosynthesis, using chemicals and minerals from the ocean floor to sustain itself. The Europa Clipper will carry a suite of scientific instruments designed to study Europa's ice and the ocean below. It will map the thickness of the ice and analyze its chemical composition, giving us clues about what lies beneath. But more than that, it will look for signs of life, organic molecules, chemical reactions, and patterns in the ice that suggest something more. Among the tools on board are spectrometers that can identify chemicals in Europa's ice and atmosphere. These instruments will look for signs of organic chemistry, the building blocks of life. By flying through Europa's plumes of water vapor, the Clipper will collect samples directly from the Moon's ocean, without needing to drill through miles of ice. These plumes may be the key to understanding whether life exists on Europa. By analyzing the chemicals in the water vapor, we can learn more about what's happening beneath the ice. If we find organic molecules, it could mean that Europa's ocean is rich in the ingredients needed for life to develop. So, what exactly are we looking for? Life on Europa may not look anything like the complex organisms we see on Earth. It could be simple, microscopic even, but its presence would still be a groundbreaking discovery. The Clipper will search for signs of microbial life, tiny organisms that live in the water or even in the ice itself. If microbes exist on Europa, they may have evolved in isolation, shaped by the cold, dark waters over millions of years. They could feed on minerals from the ocean floor, or even use chemical energy from the interaction between water and Europa's rocky core. These microbes might leave traces behind, biosignatures that the Clipper can detect. Patterns in the ice, unusual chemicals in the water, or changes in Europa's magnetic field could all be signs of life. Even if we don't find actual organisms, these signs could tell us that life once existed, or that the conditions for life are there now. One of the most exciting parts of the mission will be the search for biosignatures, indirect signs that life exists or has existed on Europa. These biosignatures could be anything from complex organic molecules to unusual patterns in the ice caused by microbial activity. On Earth, certain microbes produce methane or other gases as byproducts of their metabolism. If we find similar gases in Europa's plumes, it could be a clue that something is alive down there. Or perhaps the ice itself will show patterns that suggest biological processes are at work, like the movement of microorganisms beneath the surface. If we do find life on Europa, no matter how simple, it would change our understanding of the universe forever. We would know that life is not unique to Earth, that the conditions needed for life can exist in the most unexpected places. This discovery would not only reshape our view of the solar system, but also open new possibilities for where life might exist beyond. The search for life on Europa is about more than just one moon. It's about answering one of humanity's oldest questions. Are we alone in the universe? With the Europa Clipper, we are closer than ever to finding the answer. As we gaze toward Europa's icy surface, the thought of humans setting foot on this distant moon may seem like a far-fetched dream. But in 100 years, that dream could become a reality. Colonizing Europa will present extraordinary challenges. Its surface is an unforgiving frozen wasteland, constantly bombarded by radiation from Jupiter. Yet, humanity has always thrived in adversity, and with the right technology, we could create a foothold in this icy world. The surface temperature on Europa averages -160 degrees Celsius, and beneath that ice lies an ocean that could be 100 kilometers deep. The first challenge will be simply surviving in these conditions, and that means finding shelter from both the extreme cold and the intense radiation. Jupiter's magnetic field creates powerful radiation belts around the planet, making Europa one of the most hazardous environments for humans. Without protection, even a short stay on the surface would be deadly. To survive on Europa, our first colonies will need to be built underground, deep beneath the icy surface, where the thick ice can shield us from radiation. These colonies will likely resemble small, self-sustaining cities powered by geothermal energy or nuclear reactors, providing heat and electricity for human habitats. Living underground, colonists would be safe from the freezing temperatures and radiation while having access to Europa's abundant water, locked away in the ice above. This water could be melted and purified for drinking, while the ice itself might be mined for other essential resources. The key to survival on Europa will be self-sufficiency. Colonists will need to recycle air, water, and waste, using advanced life support systems to create a closed-loop ecosystem. Hydroponic farms could grow food in nutrient-rich water, and algae systems might provide oxygen in a way similar to Earth's natural ecosystems. But colonizing Europa isn't just about surviving, it's about exploring. The ocean beneath Europa's ice is one of the greatest mysteries in our solar system. In the future, explorers may use advanced submarines to dive deep into this hidden ocean, searching for life and new resources that could sustain our colonies. These submarines would be equipped with advanced sensors and robotic arms, capable of navigating through the icy waters, collecting samples, and even interacting with any life forms we might encounter. The discovery of alien life, whether microbial or more complex, would open up new fields of study and potentially revolutionize our understanding of biology. Colonists could be the first humans to study life from another world, making Europa not only a home, but a center for scientific discovery. Adapting to life on Europa will require more than just technological solutions. It will demand mental and physical resilience. Life in a small, enclosed habitat with limited contact to the outside world would be challenging. Colonists would need to stay healthy, both mentally and physically, in an environment that is completely different from Earth. The lower gravity of Europa, at only 13% of Earth's gravity, would pose its own challenges. Prolonged exposure to low gravity could weaken muscles and bones, so colonists would need to exercise regularly to stay strong. Their routines would include special equipment designed to simulate Earth-like resistance and maintain bone density. Mental well-being would be just as important as physical health. Virtual reality could provide colonists with a mental escape, allowing them to experience simulated environments from Earth. Lush forests, blue skies, and the sound of waves crashing on a beach, all from the safety of their habitat. In 100 years, life on Europa could be thriving. What began as a small, isolated outpost might grow into a fully functioning colony, complete with homes, schools, research labs, and industries. Children born on Europa would grow up knowing the icy moon as their home, adapting to the low gravity and cold, dark environment as naturally as we do to Earth. Life on Europa might be challenging, but it could also be rich with new experiences and opportunities. Colonists would live in a place unlike anywhere else in the solar system, exploring one of the most fascinating worlds we've ever encountered. Living under the constant watch of Jupiter's swirling clouds, colonists would be reminded every day of the extraordinary place they call home. A frozen moon on the edge of possibility, where life, both human and alien, could one day flourish. It's the year 2124, and a new day begins on Europa. For the colonists living in this icy world, the concept of morning is a relative term. With no natural sunlight penetrating Europa's thick ice, colonists rely on carefully calibrated artificial light cycles to maintain a sense of day and night. The days are long here. Each Europa day lasts about 85 hours. But the colony operates on Earth time, maintaining a familiar 24-hour schedule for work and rest. For the colonists, their morning begins much like ours on Earth, with breakfast, coffee, and a quick review of the day's tasks. Food on Europa is grown in hydroponic farms deep below the surface. Colonists enjoy fresh vegetables, grains, and even lab-grown meat, though they have to adjust to the limited variety. Breakfast might consist of a nutrient-dense smoothie, a synthetic protein bar, or some freshly harvested greens. After breakfast, the workday begins. Most colonists are scientists, engineers, or technicians, responsible for maintaining the colony and pushing the boundaries of human knowledge. Today's task, a routine expedition to explore a new ice cavern recently discovered beneath the colony. Exploration is one of the primary focuses of life on Europa. Colonists regularly venture out to map new areas of the ice, collect samples, and study the ever-changing environment beneath the surface. Every day brings the potential for new discoveries, geological formations, chemical compounds, or even microbial life. Work on Europa is about more than just survival. It's about uncovering the secrets of this alien world and contributing to a growing body of knowledge that could benefit future generations, both here and on Earth. One of the most remarkable aspects of life on Europa is the fact that children are born and raised here. For them, Earth is a distant, almost mythical place. Their education focuses not just on math and science, but on understanding their unique home and the role they'll play in its future. The children of Europa are the future of this colony. They're taught to be resourceful, resilient, and adaptable, preparing for the day when they will inherit the responsibility of maintaining and expanding humanity's presence on this distant moon. Life on Europa isn't all work and no play. After hours of scientific research and maintenance work, colonists need time to relax and recharge. In low gravity, exercise is not just a necessity, it's fun. Colonists spend time in the recreation domes, bouncing around, playing low-gravity sports, and enjoying the unique sensation of floating effortlessly. Physical activity helps maintain their health in the lower gravity of Europa, where muscles and bones would weaken over time without regular exercise. But it's also a chance for colonists to bond, fostering a sense of community in this isolated environment. As the day comes to a close, colonists have time to unwind. Many spend their evenings gazing out at the distant glow of Jupiter, reflecting on the enormity of their journey and the life they've built on this frozen world. Though they are far from Earth, the colonists remain connected to their friends and families back home, thanks to advanced communication systems. They share stories of their life on Europa, the discoveries they've made, and their hopes for the future. Life on Europa is not easy, but for these pioneers, it's a life of purpose and wonder. They are the first humans to call this icy moon home, and their efforts today will pave the way for future generations to thrive on the frontier of human exploration. After a long day, colonists dream of the future. The challenges they face today will shape the course of human history. One day, their descendants might expand beyond Europa, reaching out to other moons, planets, and distant stars. Europa is just the beginning. The spirit of exploration and discovery that brought humans here will carry us to even greater heights. As the sun sets on another day in this frozen world, the future of humanity in space shines brighter than ever. Europa is beautiful but deadly. The surface is covered in thick ice, and the temperature rarely rises above -160 degrees Celsius. the extreme cold is not the only threat. Europa is bathed in intense radiation from Jupiter's magnetic field, making the surface uninhabitable for humans. To survive on Europa, colonists live beneath the ice, sheltered from the radiation and the freezing temperatures. Advanced technologies create artificial habitats that keep them warm and protected. Generating energy on Europa is another challenge. Solar power is inefficient this far from the sun, and the thick ice blocks sunlight. Instead, the colony relies on geothermal energy, tapping into the moon's subsurface heat. This energy powers the life support systems, research labs, and habitats that make life here possible. Water, one of Europa's most abundant resources, is both a challenge and an opportunity. Beneath the ice lies a vast ocean, potentially rich in minerals and other resources that could be essential for sustaining the colony and even fueling future missions into space. Living on Europa is not just physically demanding, but psychologically challenging as well. The isolation, the distance from Earth, and the confined spaces of the underground colony take a toll on the human mind. The colonists face long periods of darkness and the knowledge that they are millions of miles from home. To cope with these challenges, colonists have access to virtual reality environments where they can experience the sights and sounds of Earth. These digital escapes help maintain their mental health, allowing them to reconnect with nature, even if only in a virtual sense. But the challenges of life on Europa have also led to incredible innovations. New technologies, developed to help humans survive in extreme environments, are pushing the boundaries of what we thought possible. Robotics, artificial intelligence, and bioengineering are all being tested and refined in this harsh setting. AI-driven robots can explore areas too dangerous for humans, while advanced life support systems and autonomous machines ensure the colony's smooth operation, even when humans can't be present. These breakthroughs on Europa could one day be used in other extreme environments across the solar system, from Mars to the moons of Saturn. Perhaps the greatest opportunity on Europa lies in its oceans. The subsurface ocean is a vast, unexplored world, potentially teeming with microbial life. Scientists on Earth have long suspected that Europa's ocean could hold the answers to one of humanity's greatest questions. Are we alone in the universe? Recent discoveries suggest that life might thrive in these extreme conditions, similar to the deep-sea vents on Earth where life exists without sunlight. If confirmed, the discovery of life on Europa would be one of the most significant events in human history, proving that life can exist beyond Earth. Living on Europa is not just about survival, it's about laying the foundation for humanity's future in space. The lessons learned here will help us colonize other moons and planets, from Mars to the outer reaches of the solar system. Europa is a stepping stone to the stars. The challenges faced by the colonists today will make future missions possible. From developing advanced life support systems to refining long-term space travel technologies, Europa is where humanity prepares for its next great adventure. 100 years from now, the first human settlement on Europa has grown into a thriving city, a testament to human innovation and resilience. What once was a barren, frozen moon has become a bustling center of life and activity. Advancements in agriculture have made Europa self-sustaining. Beneath the ice, vast biodomes produce food for the colony, while water from Europa's underground oceans is purified and circulated through the habitats. Life on Europa has evolved. Homes are now comfortable and filled with the latest technologies, designed for both comfort and efficiency. Families live in spacious underground dwellings, each home designed to be self-sustaining, using the latest in renewable energy and environmental controls. The colony has developed its own economy, driven by local resources and technology. Trade and commerce flourish as goods are produced and exchanged, with AI systems helping to maintain the smooth operation of daily life. A new culture has emerged, blending the traditions of Earth with the realities of life on a distant moon. Festivals and art, inspired by the icy beauty of Europa, have become an integral part of colony life. The children of Europa are raised in a world where space travel is normal and the stars are within reach. They learn about the history of Earth, but their eyes are always on the future, on the possibilities that lie beyond their icy home. Science has flourished on Europa. The colony's proximity to Jupiter's other moons has made it a hub for research and exploration. Scientists continue to study Europa's oceans, where new forms of microbial life are discovered regularly, opening up new frontiers in biology and astrobiology. Europa has become the gateway to the outer solar system. With advancements in propulsion technology, missions to Ganymede, Callisto, and beyond are launched from Europa's spaceports, pushing the boundaries of human exploration even further. Over the decades, the colony has developed its own systems of governance, tailored to the unique needs of life on Europa. Decisions are made by a council of elected representatives, each focused on ensuring the survival and prosperity of the colony. Society on Europa is cooperative and forward-thinking. Colonists understand the importance of working together to overcome the challenges of living on a distant moon, and social structures have evolved to prioritize the well-being of the entire colony. Though life on Europa is now established, humanity's journey is far from over. The next great mission lies ahead, exploring the moons of Saturn, venturing to distant stars, and continuing the search for life beyond our solar system. The spirit of exploration that brought humanity to Europa continues to drive us forward. With each new discovery, we move one step closer to uncovering the mysteries of the universe and securing our place among the stars. As we've journeyed through the potential discoveries of Europa and imagined what life could be like on this distant moon 100 years from now, we've only scratched the surface of what the future holds. The upcoming missions to Europa might not only uncover the mysteries of this icy world, but could also change our understanding of life in the universe. And one day, perhaps, Europa could become a second home for humanity, a beacon of hope and progress in the far reaches of our solar system. The future of space exploration is filled with endless possibilities, and we are living in a time when the dreams of interplanetary travel and colonization are closer than ever. From the first signs of life in Europa's ocean to thriving colonies beneath its icy surface, our curiosity and innovation will push the boundaries of what we believe is possible. We've only just begun to explore the universe. Imagine what else we might find out there, waiting for us. Thank you for joining us on this incredible journey through time and space. If you enjoyed this video and want to be part of our exploration of the future, don't forget to like, share, and subscribe to our channel. Together, we can keep exploring the cosmos, one discovery at a time. Until next time, keep looking up and wondering what's out there.